Hi friends, this is Naresh. In this class I am going to explain about engineering drawing, and today's topic is involutes. In this class I will explain about rectangle, square and triangle involutes. First of all, an involute is the locus of a point on a line as the line rolls along a shape. It can also be thought of as the locus of a free end, the locus of a free end of a string when it is wound or unwound around the circumference of a plane figure. Okay, this is the best example for circular involutes. Now I will explain the applications of involutes in in industries. These two are the pulleys. In many mechanical machineries, you have to transfer the power from one shaft to another shaft through pulleys and gears. For pulleys, you have to transfer power from one shaft to another shaft by using belt connection. So by using these involutes concept, involutes are used to determine the length of the belt required. So by using these concept, you will find the length of the belt required to transmit the power from one shaft to another shaft. Okay, and another application is involutes are also used to calculate the amount of material required to create tires and wheels. Okay, now coming to the problems. Draw the involute of a square of side 20 mm and draw tangent and normal at any point M on it. Okay, so here you have to construct the involute, square involute. The side of the square is 20 mm. So first of all, you have to draw a square ABCD of side 20 mm. So first step is draw a given square ABCD, of side 20 mm. Here each side is 20 because it is a square. ABCD. Okay. Now draw tangents. Draw tangent lines from point A, B, C, D as shown in figure. So next step is you have to draw tangent lines from all points A, B, C and D. Okay, this is A, point B, point C and point D. Okay, now with A as center, here A as center and radius AD equal to 20 mm, 20 mm as radius. Draw an arc. So you have to consider A as center and radius AD equal to 20 mm. Draw an arc. Draw an arc to cut the line AB produced at point P1. Similarly, B as center, BP1 BP1 as radius, draw an arc. Draw an arc to cut the line CB produced at point P2. Okay. Similarly, C as center, C as center, and radius equal to CP2. CP2 equal to 60 mm as radius. Draw an arc to cut the line CD produced at point P3. Okay. Now similarly, D as center and radius equal to dp3. dp3 equal to 80 mm. Draw an arc to cut the line AD to produce at point P4. Okay, this is point P4. Now this is the our required shape of involute. Okay, now now you have to draw the tangent on normal at any point M on curve on involute. So to draw the tangent normals, let us consider a point M. Point M lies on the arc P3 and P4. Okay, here I consider the point M on this curve. Okay, this you may also consider here. Now the center of this arc P3 P4, the center of the arc P3 P4 is the point D. Okay, the center point of arc P3 P4 is D. Therefore join point D and M and extend it, which is the required normal line, at point M. Okay, this is normal line at point M. Similarly, at point M, draw perpendicular line to the normal line to obtain the tangent. So you have to draw a perpendicular line here. This is our required tangent line. Okay, this is normal line, this is tangent line. So this is the final figure of square involute. Now coming to the another problem. Draw the involute of a rectangle of side 20 mm and 30 mm. Draw tangent and normal at any point M. So here for rectangle having two similar sides, so two equal sides, therefore first of all you have to construct a rectangle of sides 20 mm and 30 mm. So draw an given rectangle ABCD. So here I consider horizontal line as 20 mm and vertical line as 30 mm. Okay. Now draw tangents from all points. So now I am drawing the tangent lines from point A, B, C and D. Okay. Now with A as center and radius equal to AD. Okay, with center A as center and radius equal to AD, draw an arc to cut the line AB, to cut the line AB produced at point P1. Okay, this is point P1. Similarly, B as center and radius equal to BP1. Okay, B as center and radius equal to BP1. Draw an arc to cut the line CB and produce at point P2. Okay, similarly, C as a center and radius equal to CP2 to cut the line CD. So CP2 radius, C as center. Draw an arc to cut the line CD to produce at point P3. Similarly, D as a center and radius equal to DP3 to cut the line AD. Okay, D as center and DP3 as radius. Draw an arc to cut the line AD produced at point P4. So this is our required shape of involute of a rectangle. Now you have to draw the tangent or normal at any point M on it. So here I consider a point M on curve on arc P3 P4. Okay, here I consider the point M on arc P3 P4. So you have to draw the tangent or normal at this point. Okay, now the center of the arc P3 and P4, the center of the arc P3 and P4 is point D. So you have to join the point D and M. Okay, and extend this line, which is the required normal line at point M. Okay, this is our required normal line. Now draw a perpendicular line. Draw a perpendicular line at point M and draw the perpendicular line perpendicular to this normal line. Okay, to obtain the tangent line. Okay, this is our required tangent line. This is the normal line. So this is the final shape of rectangular involute. Now coming to the another problem. Draw the involute of an equilateral triangle of side 25 mm and draw tangent and normal at any point M. So in this case you have to construct the involute for equilateral triangle having same sides. So each side is 25 mm. So first of all you have to construct a triangle, equilateral triangle of side 25 mm. Okay, this is equilateral triangle having equal sides, that is 25, 25 and 25. The angle between each corner is 60 mm. Sorry, 60 degrees. The angle between each corner is 60 degrees. Draw tangent lines from points A, B, C as shown in figure. Okay, you have to draw a tangent lines from each point. Now with A as center and radius equal to AC. So A as center and radius equal to AC. Draw an arc to cut the line AB. Okay, draw an arc to cut the line AB and produced at point P1. Similarly, B as a center and radius equal to BP1. Okay, here B as a center and BP1 as radius. Draw an arc. Draw an arc to cut the line BC to produce at point P2. Similarly, C as a center and radius equal to CP2. Okay, here C as C as center and radius equal to CP2. Draw an arc to cut the line AC to produce at point P3. Okay, this is the our required shape of involute. Now you have to draw the tangent and normal at any point M, at any point on involute. So here I consider the point M on arc P2 P3. Okay, I consider the point M on arc P2 P3. Okay, this is the point M. Now the center of the arc P2 P3, the center of the arc P2 P3 is point C. Okay, point C is the center of the arc P2 P3. So you have to join the point C and M. Join the line and extend it, which is the required normal, normal line at point M. Okay, this is our required normal line at point M, and draw a perpendicular line. Draw a perpendicular line to the normal at point M to obtain the tangent line. Okay, so you have to draw a perpendicular to the normal line. This is the tangent line, this is the normal line. This is the final figure of equilateral triangle involute. Now coming to the another problem. Draw the involute of a triangle of sides 25 mm, 20 mm and 30 mm. Okay, draw tangent and normal at any point M. In this case, it is not an equilateral triangle, it is isosceles triangle. Okay, so first of all you have to construct a triangle by using the given dimensions. Here I consider the horizontal distance as 25 mm and left side as 20 mm and right side as 30 mm. Okay, first of all you have to construct a triangle by using these dimensions. Then after you have to draw tangent lines from points A, B, C. Okay, you have to draw a tangent lines from A, B and C like this. Now A as center and radius equal to AC. Okay, A as center and radius equal to AC. Draw an arc to cut the line AB produced at point P1. Okay, similar way B as center and BP1 as radius. Here B as center and BP1 as radius. Draw an arc to cut the line BC produced at point P2. Okay, this is point P2. Now similarly C as center and radius equal to CP2. Here CP2 as radius and C as center. Draw an arc to cut the line AC. Okay, to produce at point P3. This is our required shape of involute. Now you have to draw a tangent and normal at any point on involute. So I consider the point M on arc P2 P3. Here I consider the point M on arc P2 P3. This is the point M. Now the center of the arc P2 P3 is point C. Okay, point C is the center of a arc P2 P3. Therefore you have to join these 2 points. Join point C and M. Join point C and M and extend it, which is the required normal line at point M. Okay, this is our required normal line at point M, and draw a perpendicular line to the normal at point M to obtain the tangent line. Okay, this is our required tangent line. So you have to draw a perpendicular line to the normal, okay, at point M. This is the final shape of our required involute. Thank you very much.